All right, so greatest common factor, GCF factoring, that's what we are starting off with today. So greatest common factor, who remembers what that means? How do we factor using that method? What do we look for? What they have in common. So if we look at the first one, what do they have in common? A 5. So our GCF for this first one would be a 5. Do you have to identify what the GCF is every time? No, I'm just doing it as a little refresher right now. So remember, we set it up. The GCF, their common element, goes in front of a set of parentheses. And it's always just one set of parentheses initially unless you factor again, but that's a different day. And then remember, to get the stuff inside the parentheses, we go up here and divide by that common term. So in this case, we're dividing both by 5. So we would get x minus y in there. That is our factored form. This has 2 factors. The 5 is one of your factors. Everything in the parentheses is your second factor. So your second factor would be the x minus y. And I always point that out because a lot of times they ask that and kids don't realize that. You got 2 factors there. You've got the number 5 and then the x minus y. All right, let's look at the second one here. What do they have in common? 1/2 and n. So that is what our GCF is going to be. So again, I do my little setup. I put my 1/2 n in the front. And then do one set of parentheses. And to fill in the parentheses, I divide by 1/2 n. So then the first term, when we divide by the 1/2 n, we're left with an a. Basically, it just gets rid of that 1/2 n. And the second one, what are we left with? A negative b. So 1/2 n minus and times a minus b. And then our third one, we got 3 terms this time, so we got a trinomial here. What number goes into all 3 of those numbers? 3. Do they have any common letters? C and D. So remember, with the letters, before in our first one, it was just n, no big deal. But there's different exponents here on the C. We got a third, a second, and then a c to the first. So which one do we use in our GCF? The first. You always use the smaller exponent. So we would use c to the first, and then we would use d to the first also. So our lowest exponent on our d is also a 1. So 3cd is our GCF. I make my parentheses a little bit bigger this time because I have a trinomial, so that means inside my parentheses I'm also still going to have a trinomial. So then I divide each of those 3 terms via the 3cd. So the first one, when I divide 6 divided by 3, gives us a 2. Subtract our exponents. So remember that c we're dividing by, it's got an exponent of 1. So when I subtract those exponents, 3 minus 1 gives me a c squared. What would be our exponent on the d there? Nothing. Don't they have the same exponent? So they just cancel each other out. They're both an exponent of 1. Bam. b is gone for that first term. Second term, 12 divided by 3 gives us a 4. C squared divided by c gives me c to the first, because 2 minus 1 gives me a 1. A squared divided by d gives me d to the first. So there's our second term. And then the last one, 3 divided by 3 gives us a what? 1. Anything divided by itself is 1. And then those exponents on your letters are both the same, so those cancel out. So all you have there is the 1, and yes, the 1 has to be there. It's crucial. It's a placeholder that's got to be there. So there's our GCF factor. So now that we've gone through the method, I want you to take just a few minutes look through these practice ones that I put down here. There's 10 of them. See which ones you can do. If you can't do all of them, that's fine. We're going to definitely go through them. But I want you to look through, see which ones you can do, because whichever ones you guys can do, I don't want to spend too much time on those. All right, let's take a look at number 5. What's our GCF in number 5? 12x squared. So that's inside the parentheses. Remember, we go up here, divide both of these by 12x squared. 12 divided by 12 gives me 1. Subtract my exponents, I get x to the first power. Do I have to write that 1 out in front? No. You could have the 1 there. That's not wrong. But if you have it as simply x, that is also the same thing. So remember, mathematicians get lazy. We don't always put a 1 coefficient there. 144 divided by 12. 12. And then those x's cancel because they have the same exponent. So it's just 12 is your last term there. How about for 6? What's our GCF for 6? 5x. So then inside, once we divide each and every term by 5x, we should get x squared plus x minus a 2. Hopefully GCF factoring is coming back to you a little bit. Now these last 4, these ones were definitely more difficult. I'm going to put a star by 10 because that one is the toughest problem on here. So 7, again, it's a lot of letters. I know people get confused because they're looking at it. They just see a whole bunch of A and B's and numbers there. So you want to look at each part separately. So looking at the numbers, what's our GCF for our numbers? 2, because you got 4, you got 2, you got 10. 2 goes into all 3 of those. Oops, I didn't mean to put that there yet. So for our A's, what's our lowest exponent on A? Just a 1, so it'd be a to the first. And then our lowest exponent on our B would be a 1 again. So we want to divide all 3 of these by 2ab. So you would get 2 minus ab plus 5a squared b squared. Always subtracting those exponents when you're dividing here to get your parentheses. 8. Some of them have A, B, C. Like if you look at your second term, there's no C. So is C going to be part of our GCF? No, because there's no C with that term. It's not a common thing with all 3 that are there. So looking at our A, lowest exponent is a 1. Lowest exponent on our B is a 1, so AB is our GCF for number 8 there. So we go and we divide, and we would get a squared BC plus 3ab plus 10c. Anyone get that on their own? Yes, a couple people. Awesome. All right, 9. Does 12 go into 60? Yep. So 12 is our GCF. Looking at our x's, I got a 3, a 2, a 1, so x to the first, and then y to the first. Those are my lowest exponents. So 12xy is my GCF there. Divide by 12xy, and I would get x squared. The 12s would turn into a 1, which I could write it. It would be 1x squared. Divide by 12xy, and I get 12xy plus divide by 12xy, 5y squared would be our last one. How do we do with that one? Thumbs up, thumbs down. All right, now number 10, starred next to it because this time your GCF isn't a single term. All of your GCFs have been monomials, just one term, 12xy, 2ab, 12x squared, ab, 5x, all our other examples. Your GCF was a monomial. It was one term. In number 10, your GCF is a binomial this time. It's a 2-term thing. So if you look at the first term, which would be all of that stuff, 4 parentheses x minus 2, that is your first term. Our second term is 7y times the x minus 2. What is it that those 2 terms have in common? the x minus 2. That's our GCF this time. That x minus 2. So instead of pulling out just a single term like we did on all the other ones, we're going to put the x minus 2 first. And you're going to keep it in parentheses because it's a binomial this time instead of a monomial. Just to see that it's similar, I could have put all of these monomials in parentheses also. So you could have still had two sets of parentheses, but you didn't have to when it's just one term. So again, here's your GCF, just like in all our other ones. GCF comes first. And then I set up my other set of parentheses. When I divide by x minus 2, it cancels the whole thing. X minus 2 cancels with x minus 2. So in that first term, all that's left is that 4. And then over here, x minus 2 cancels with x minus 2. So all that's left is that 7y. So 4 plus 7y is our other term. Tricky, but doable. You guys can do that. So this really should be difference of two perfect squares. But DOTS just was weird to say, so they just shortened it to difference of two squares. But that's the key thing is they have to be perfect squares. So you guys have to remember what your perfect squares are. So I always make a little list over here. When it comes to exponents, an even exponent is a perfect square. I'm going to shorten it down to PS. Even exponents are perfect squares. So if you look at our first examples that I have up there in the box, we got an r squared, so that's perfect because 2 is even, and then x squared, and then another x squared and a y squared. So as long as that exponent is even, it is a perfect square. And then when it comes to your numbers, you should have your perfect squares memorized. If you don't, then let's work on that because your life is going to be easier if you have these things memorized. Otherwise, you could be in the middle of the problem and you're stuck trying to figure out if something's a perfect square or not, and that could take you a while, and then you just get lost in the problem where you are. So knowing these facts, your multiplication facts, knowing your perfect squares, is just going to make things go smoother for you. So if we look at our first example here, as we just said, r squared, we already know that is a perfect square. So if we look at our number, is 9 a perfect square? Yep, it is. It wasn't a trick question. Yeah, it is. 3 times 3. That's how we get 9. So 9 is a perfect square. The other thing is it needs to be a subtraction. I can't tell you how many times I've seen on an exam where they write r squared plus 9 because they want to throw you off. That is their goal, is to throw you off. So they write that one, and then most people factor it like it's a dots problem because you see the two perfect squares. You ignore the fact that this is a plus sign. Difference means it has to be a subtraction. So that one is not a dots. It wants to be a dots, but just isn't quite there. So our setup, 2 sets of parentheses. Within your 2 sets of parentheses, one is always positive, one is always negative. It does not matter which one goes first. You can put positive first, negative last, or vice versa. Negative first, positive last. That order doesn't matter. So then to get the stuff inside the parentheses, you're going to take the square root of your of your first term. In this case, it's our variable, the r squared, which with any exponent, all you have to do is divide that number by 2. So 2 divided by 2 gives me r to the first and r to the first, and those go in the first 2 spots because it's the first term, first 2 spots. And then you take the square root of the second one. What's the square root of 9? 3. So you write that in the other 2 spots. So r minus 3, r plus 3. Or r plus 3, r minus 3 as I have written. All right, let's look at the next one. 25x squared. Is the 25 a perfect square? Yep. Is x squared perfect? Yes, because it's even. So we got a perfect square here. How about the fraction? Is 1 a perfect square? Yeah, 1 times 1 is how we get 1. It's a perfect square. Is 49 perfect? Yep. So then the whole fraction is. So since the top's a perfect square, the bottom's a perfect square, the whole fraction is a perfect square. So we'll set up our parentheses. Just because the order doesn't matter, I'll switch it up and put my negative first this time and then my positive. So again, now I'm going to take the square root of my first term. What's the square root of 25? 5. And then the square root of x squared? X. So our first terms are going to be 5x and 5x. The square root of the first one goes in the first spots. For the fraction, you're going to take the square root of the top and the bottom separately, and that makes your new fraction. So the square root of 1 is 1. Square root of 49, 7. So when we take the square root of the whole thing, it becomes 1 over 7. And then we're done. Let's look at our third one. We got 2 perfect squares. 4 is perfect, x squared is perfect, so that whole first term is perfect. 81 is perfect, y squared is perfect, so that whole term is perfect. So what is the square root of 4x squared? 2x. So 2x goes in my first spots. And then what is the square root of 81y squared? Close. 9y. And 9y. So 9y goes in our second spot. So our rule here, because some people do well if you know the rules, a squared minus b squared when you factor is the square root of a squared. So a is your first spot. Square root of b, square root of b. That goes in your second spot. One's minus, one's plus. As you're going back to study this, let's put this little note here. Take these square roots. So that is what we're doing each and every time, taking the square roots. So let's look at this first one. We got a squared minus 64. So is a squared perfect? Yep, 64 perfect? Yes. So that's always should be the first thing you're doing in your head, is figuring out, are they both perfect squares, and then do they have that subtraction sign that you need? So the square root of a squared is a. Square root of 64 would be 8. I ate and I ate and I got sick on the floor, so 8 times 8 is 64. Never forget the first time my nephew told me that when I hadn't heard it. How about number 2, the one to the right of it? Are those perfect squares? Yes. Anybody that got it yet for number 2? Good. So, because we aren't going to have enough time to do all of the classwork that I wanted to do, let's look quickly at 5 and 6. Are those ones still dots? What if I follow my commutative property and I just change my order? Are they dots now? Yeah. Sometimes you just need to, commutative property, change your order there, and then you can see it. So what I want you to do is take a few minutes. Again, try the ones you can. If you can't get them all, that's okay. We're still learning. But try them all. Let's see what we get. All right, so just because we're running low on time, I'm going to slowly start filling these in. So for the third one, it was 3 plus a, 3 minus a. Fourth one, 9 plus a, 9 minus a. How we do so far? Good. Thumbs up, thumbs down. And then we got w minus 5, w plus 5, r minus m, r plus m. Again, it doesn't matter which order. You could have your plus first, minus second. I keep flip-flopping to get you to understand the point. It doesn't matter which one of those comes first. So for 7, it would be 9c minus 5, then 9c plus 5. 9 plus 2b, 9 minus 2b. And then 2m minus n, 2m plus n. And we got 2r and 7p. 1 plus 1 minus. And then 10a, 9b. Again, 1 plus 1 minus. And then 6ab. When they finally changed the exponent on you, it wasn't just an x squared. It was an x to the 4th. So if you divide that 4 by 2, it would be x squared plus 7x squared minus 7. Always divide that exponent by 2. That's how you take the square root of it. And 3 plus y, 3 minus y. And then our last row, 9 and 5m, 4 and 12n.